introductory class of digital electronics. So before going to digital electronics, let us discuss the concept of signal. So what is a signal? Signal can be described as the function which represents the variation of a physical quantity with respect to any parameter. The variation of a physical quantity with respect to any parameter can be called as a signal. And here the parameter can be either time or distance. But in our electrical or electronic circuit, the physical quantity will be voltage or current, and the parameter of variation will be with respect to time. So let us discuss a function, a typical function whose equation is given by minus ax square plus bx plus c. So you would have probably studied about this function in your mathematics classes. Now let us study the variation of a physical quantity, that is temperature, with respect to time. So suppose we are going to a place and we have to measure the temperature from morning 9 am to 9 pm. So you will have to first plot the graphs, like the temperature at 9 am would be, let us say, 27 degrees Celsius. The temperature after 1 minute variation, that is 9:01, would be suppose 28 degrees Celsius, and so on till 9 pm. And if we plot a graph, that is, here it is the x-axis and here it is the y-axis. Now we are taking the temperature in the x-y axis and the time in the x-axis. Let us start from 6 am. So this point is 9 am, this point is 9 pm, and this point is 11 pm. So the graph would be like this. Suppose at 9 am the temperature is here, and at 9:01 the temperature increases, and after some time it reaches a maximum value, and then it decreases till 9 pm. From the graph we can clearly say that the graph is a downward parabola. So here we are representing our signal in a form of a mathematical parabola equation. So from equation, that is minus ax square plus bx plus c, this a, we know from our mathematics classes that if this a is greater than 0, then we will obtain a downward parabola. If this a is equal to 0, then we will obtain a straight line equation, because we will obtain function will be equal to bx plus c, that is, as we know, y equal to mx plus c. This is the equation of a straight line. And if the function a is less than 0, then we will obtain a upward parabola. Now here we can express the signal as a function of the physical quantities. Now in electrical circuit we are using a device, and that device is called transducer. So what is the function of this device? The transducer is used to convert the non-electrical signal into the electrical signal. And there is another device that is called reverse transducer. A reverse transducer converts the electrical signal into the non-electrical form. So how these transducers are used? Let us say we are using a mic. This is the example of a mic. So you are providing the input to a mic, that is the sound input. The mic will receive the signal and will convert into its electrical form. It will process and amplify the signal here. That is, the signal is still in the electrical form. And when it will give the output through a speaker, you will obtain again the sound form. That is, in this case, we are using both transducer and reverse transducer. So, to convert the electrical signal into the non-electrical form and its reverse process, we need the application of a transducer and a reverse transducer. Let us come to the classification of signals. Signals can be classified into two types, that is analog signal and digital signal. Clearly, we have drawn a figure of an analog clock and a digital clock. So, analog signal is the signal which varies continuously with respect to time, and the digital signal varies discretely with respect to time. And the digital signal has a defined particular levels. So now we are saying the signal which continuously varies with respect to time can be called analog signal, and the signal which do not continuously vary or which discretely vary with defined levels are called digital signals. Now, the analog signals can be expressed by the sinusoidal waves. That is, graphically they can be expressed like this. And the digital signals, they can be defined in form of square waves because they have only two values, that is only 0 and 1. This is the example of a square wave. The lower value is 0, the higher value is 1. So now, here it is represented by a sinusoidal wave because there are multiple number of values in the analog signal. Again, when there is a case of low bandwidth, analog signal is used. When there is a condition for high bandwidth, the digital signals are used. In the analog signal, we have more noise. So first of all, let us tell what is noise. Noise in our electronics is defined as the unwanted signal or the disturbances produced in the signal. So we can say that the noise is more in case of analog signal and the noise is very less in case of digital signals. Now, if we express the parameters of analog signal, the parameters will be amplitude, phase, frequency, etc. But the digital signals, the parameters are bit rate, bit interval, etc. Now, where the analog signals are used? The analog signals are used in expressing the sound, temperature, intensity of light, and the digital signals are used when the data is transferred between two devices. So, basically the analog and digital signals can be differentiated as the continuous variation and the discrete variation. Hope you get the basic concept about the signals. Thank you for watching.